Time for organic chemistry. Now, organic chemistry is just carbon chemistry, where carbon is the principal atom. And the molecules that are involved in organic chemistry are from a biological nature. Now, that's either living right now kind of molecules or once living. Carbon chemistry. Now, not all carbon types of molecules or molecules that have carbon in it are organic. Like carbonates, like sodium carbonate, Na2CO3. Nope, that's not organic. Carbonates aren't organic. You know, on the periodic table you might find that polyatomic ion called cyanide, Cn negative. That's not organic either. And a lot of oxides of carbon aren't organic too. It's basically hydrocarbon chemistry. So it's carbon atoms with hydrogens bonded to it, and sometimes some oxygens and nitrogens too. Now, what we're going to concentrate on is what normally happens in high school and first year university type of organic chemistry, which is just to get the nomenclature, or how to name these molecules down, plus some very important reactions. Now, before we get into that nomenclature kind of thing, here are some ways that formulas are going to be shown in the organic chemistry unit. Now, here's a formula for our organic molecule, C2H6. It's called ethane. I'm going to tell you about that a little bit later. Now, here's ethane, and that's its formula, so we're all very familiar with that. Now, the structural formula, how it's shaped, but only in two dimensions, on a flat piece of paper or on a board like this, C2H6 could be drawn using this structural formula. Well, not could be, it is. Now, that's the structural formula. When you see it written out with the bonds in it, that's a Lewis diagram though, isn't it? So that's a structural formula. But you can say that this is a C with 3 H's and a C with 3 H's, and so CH3, CH3, that's called a condensed structural formula. You can see any of those, especially in a textbook, so be aware when you see these types of formulas what they really mean and how they want you to build it. This is just a CH3, CH3. Now, look down here, here's propane, C3H8. Here is its structural formula, and then we have a condensed structural formula. Sometimes you see a condensed structural formula with the lines actually in between the carbons as well. Don't get freaked out, it's just a condensed structural formula with lines in it. Now, there's also something called a line diagram, where some scientists who get kind of lazy, they just don't even bother with the carbons anymore. And by the way, you're going to see that what I'm going to do is, I'm not going to bother writing in a lot of the hydrogens anymore. When you write a structural formula and you put just lines off of carbon atoms, what you're doing is you are intimating that there are hydrogens off of that carbon. And so instead of drawing those H's all over the place, we just draw the C's in with a bunch of lines. Okay, it would look like that, right? A line diagram for ethane is real simple. There. But that's a line. Yeah, I know, it's just a line. And that line intimates or suggests that there's a point here which has a carbon and a point that has a carbon. And so that line, which is a single bond, in between the two carbons gives you ethane. So then what would this one be here, this propane? Well, it would be like that. 1, 2, 3 points. And so when you got your 3 points, that's your C3, and then with H8, that's propane. Now, let's go on to the next one, where we're going to start talking about how to name these things like ethane.